As a teacher, as somebody who was trying to teach him, you know, you get the impression that you're not necessarily that what you're saying is getting through, and yet it got through and it was amplified tremendously at the other end, and he deserves the Turing Award.
I know of Jack's work through my history as a researcher and a manager in the field of high-performance computing. I think that Jack's technical contributions to the field of scientific computing and high-performance computing are truly foundational. I think anybody who's spent time working in the field has used extensively the tools that Jack developed or that were inspired by his work in a very robust way.
Jack's work on numerical linear algebra libraries and the development of LINPACK as a benchmarking metric for parallel and large-scale supercomputers, those have both had a profound impact on both my teaching and my research and on the national supercomputing community generally.
The center of all of numerical computation is linear systems. This is what IcePack and what LINPACK are all based on linear problems. The reason that happens is that we try to solve problems like weather problems or flying an airplane or whatever by simulations, and those are all nonlinear problems. How you solve nonlinear problems is you take a place where you want to figure out how it's behaving, linearize everything at that point so that you can solve it, and then move it to the next point. As solving it gives you an approximation for the next point, and you do the same thing again and again and again. So you end up with solving linear systems many times to get at the answers to nonlinear problems like weather forecasting, how airplanes fly, fluid flow, all the scientific problems. In physics, the people who do black hole analysis, all that sort of stuff eventually ends up down to a linear system, and that's what Jack would then provide them with: efficient, effective, the fastest code you could find.
Most importantly for my own research, these packages have included efficient eigenvalue solvers, and as a theoretical and computational scientist, I not only run other people's codes, but I also develop algorithms and then implement them myself in Fortran, C, and C++. And for doing that kind of work, it's essential to have efficient mathematical software. And ScalaPack in particular has provided the foundational parallel linear algebra subroutines that have been absolutely essential in my work and in quantum chemistry and electronic structure.
I think that really turns around this idea of connecting the world's fastest computers to some of our hardest technical problems in a way that is efficient and allows us to solve things with the clarity and the insight that we just wouldn't be able to get any other way. By foundationally enabling that connection between theory and experiment, computing and Jack have been able to terrifically advance our understanding of the natural world.
You want reliable, robust, effective, efficient software all the way along so that you know your answers are going to be likely useful for your science. And that's what he's known for, and that's what he did very well. That was what his emphasis was.
For the hardware to be truly applicable to the problems, you have to have this intermediate software layer. The operating systems and the tools and the applications, we normally say, the codes that actually put it all together and are used to solve a problem. And Jack has contributed in critical ways in all of those layers. And the U.S. has been a true leader in that field for decades, really since the inception of electronic computing. And it's been our ability to work across all of that dimensionality that's, I think, has been probably the most critical element. And it turns out that the University of New Mexico has played a really seminal role in that through the contributions that Jack made and several other critical leaders in the field. And so the vision of the effort there that Jack helped to set and the historical contributions made there have really been quite important.
It was quite the revelation to know that I had crossed paths in some way with this very distinguished history, you know, of people in the scientific software and computational science community, and it had such an immediate connection to them through the University of New Mexico. It was kind of wonderful to think about.
It was amazing what he did. I mean, having grown through that era, we're trying to remember what things were like in the early days, and what Jack managed to do by his personality, getting stuff out, getting people to think, getting people to advance everything was just amazing. I mean, he still is an incredible person in the sense of being able to encourage very, very bright things to happen. And you know, he's bright himself, but I mean, a lot of his, I think his tremendous contribution is he's built teams of people, all of which are accomplishing tremendous amounts, all being led by him. He's an amazing man.